Hello, ladies and gentlemen. Today we're going to cover Unit 0.3, which is Systems of Equations. So this is the last lesson of our review unit. And Systems of Equations is a concept that we've done maybe in the past in previous algebra classes. But what I'm going to do is I'm going to start off by showing you the different methods, substitution, elimination, with a 2x2. A 2x2 system of equations is where we have two variables and then we have two equations. Then we're going to transition to a 3x3, just like we have here, where we have three variables and three equations, and how to solve those types of equations by hand. And then at the end of the lesson, we'll talk about how to use our graphing calculator to create matrices to be able to solve our systems of equations, okay, to make it a little bit easier for ourselves. So let's get right to it. So I have a system right here where these are lines, and when I'm doing a system of equations, I'm looking for basically a solution. That means where if we take these two lines and graph them, we're trying to find the point in which they intersect, okay? And we're going to use our first method here, which is substitution on part A, and then we'll do elimination in part B. So substitution is another word for replace. So we're going to take a variable and we're going to replace it and put it in terms of the other, okay? So when I look at my two equations here, I'm going to take the second one. I'm going to label this 1 and 2. I'm going to take the second one and I'm going to rewrite it and put it where y is by itself. So to do that, I'm going to subtract 2x to both sides, okay? And this is going to give me y equals negative 2x minus 7. Okay, and I'm going to take what y is in that second equation. Y is negative 2x minus 7. And I'm going to substitute it into the other equation for y. Because we know that y is, that equal sign meaning is, negative 2x minus 7. So I'm going to replace it for what the y is in the first equation. So then we have 3x plus 2 times negative 2x minus 7 is equal to negative 9. Now, the next step here is we have to do some distributing because we have to combine like terms and solve for x. So we're going to take this 2 and multiply by negative 2x. So we got 3x minus 4x. And 2 times negative 7 is negative 14 is equal to negative 9. Then we're going to combine these like terms. We're going to get negative x minus 14 is equal to negative 9. Then we're going to add 14 to both sides. So add 14 to both sides. And this is going to give us negative x is equal to, I'm bringing all this up here. 14 minus 9 is positive 5. Divide by negative 1. Divide by negative 1, we get x is equal to negative 5. So you notice I was just getting x by itself. I did the opposite of multiply by negative 1 and divide by negative 1. So I found what my x is. Okay, now that we have found that value, we have to find the y value because it's a point, and a point is x comma y. So we're going to take negative 5, we're going to put it back into one of these equations. It doesn't matter which one, but usually there's an easier one to choose. And in this case, we're going to use this equation because that's going to give us what y is. Y is negative 2 times x, x being negative 5 minus 7. So I have y equals negative 2 times negative 5 minus 7. And so this gives us y equals negative 2 times negative 5 is positive 10. Minus 7 gives us y equals 3. So we just found the y value. Now we have to write this as a point. And when we write a point, we write x comma y. So you got to make sure you put it in the right order. X comma y. So this would be negative 5 comma 3. And there is our point of intersection. That's where these two lines here are going to intersect. They're going to intersect at that point, negative 5 comma 3. Okay, so let's go do the same system of equations. So we're going to get the same answer. We're going to get that negative 5 comma 3, but we're going to use a different method, which is elimination. And when you see the word elimination, you're going to think to remove, right? So elimination is to remove or get rid of, okay? So we're going to get rid of a variable right off the bat. So we're going to eliminate it. Now, to eliminate something, you have to do the opposite of it. So let's say if I had 2y, in order to get rid of completely the whole y, I would have to subtract 2y. Okay, because 2y minus 2y, that's going to give us 0. They cross out. Okay, so that's our goal here, is when we eliminate a variable, we're trying to do the same coefficient but opposite signs. Remember that coefficient is a number in front of a variable, a letter. Okay, so to do this, we look, okay, we got the first equation, the second equation. I want to eliminate my y's because I notice that I have a 2y and I have a 1y. So I'm going to multiply the second one by -2. Okay, so that when I do this, I got -4x minus 2y, because -2 times 2x is -4x. -2 times y is -2y. -2 times -7 is +14. So yeah, I multiplied every single term by -2. Then I'm going to rewrite the first equation on top of it. You can do it on top of it or below it, doesn't matter. And I'm going to eliminate my y's because those give us 0. 3x minus 4x is -1x. I'm just going to put in -x is equal to 14 minus 9 is 5. Now, if you look here, this here is the same line that we did here. When we right here. Okay, so we're doing basically the same thing. We're going to do the opposite of multiplying by -1. We're going to divide by -1. So we got x is equal to -5. Okay, so we found our x. Now we have to take what x is and we have to put it back into one of the equations. So it doesn't matter which one you choose. I'm going to choose, let's say, the first one. Okay, so I have 3 times -5, because x is -5, plus 2y equals -9. Okay, and then I'm going to solve. 3 times -5 is -15, plus 2y equals -9. Then I'm going to do the opposite of subtracting 15. I'm going to add 15. So I got 2y is equal to 15 minus 9 is 6. Opposite of multiplying by 2, divide by 2. So I got y is equal to 3. Okay, so I found my x and my y, write it as a point, -5, comma 3. And that is the same thing that we'd gotten when we did substitution. Okay, so that was a 2 by 2 matrix. Okay, now we're going to go into 3 by 3 matrix, and that's where it gets a little bit more complex, but we totally can do this. Okay, so in order to solve a 3 by 3 matrix, we have to cut these down into smaller systems of equations where they have 2 variables. Okay, so it says here, the addition property of equality allows us to add 2 equations together to produce a third valid equation. Create a system by adding equations 1 and 2 and 1 and 3. Why is this an effective strategy? So we're going to take the first equation being 2x plus y plus z is equal to 15. Then we're going to take our second equation, 6x minus 3y minus z equals 35. And we're choosing that as our effective strategy because it eliminates our z's. You notice we have a positive z and a negative z. So that when we add down, we got 2x plus 6x is 8x. 1y minus 3y is -2y. And this equals 50. Okay, so we're gonna take our new equation, we're gonna put it over here. Okay, now we're gonna take equation 1 and 3, and we're gonna do that one. So 2x plus y plus z is equal to 15. And our third equation, which was -4x plus 4y minus z is equal to -14. Notice we use that one because look, positive z, negative z. This eliminates, so we have -2x because 2x minus 4x is -2x. 1y plus 4y is 5y equals 15 minus 14 is 1. Okay, so we have that equation. So we're going to put that over here, negative 2x plus 5y equals 1. Okay, and we know that this is an effective strategy because this is an effective strategy because the z variable was eliminated. Okay. So I come over here. I now have a 2x2 system like we had done up here when we did these two types of methods. So I'm going to say, okay, which method should I use, substitution or elimination? And elimination stands out to me because I see that it's going to be tough to get a variable by itself. So I'm going to do elimination, and I'm going to eliminate my x's. The reason I'm going to eliminate my x's here is because I want to only multiply the less I multiply, the less work I have to do. If I did y's, I would have to multiply the top one by 5 and the bottom one by 2 to get positive and negative 10. So if I do the bottom one and multiply it by 4, that's going to just eliminate the x's. It's multiplying only one of the equations. So I'm going to rewrite the first one, 8x minus 2y equals 50. And then I'm going to multiply the second one by 4. So this gives us negative 8x. 4 times 5 is positive 20y. 4 times 1 is 4. And you'll notice that those x's cross out. So 20y minus 2y is 18y. 50 plus 4 is 54. I'm going to do the opposite of multiplying by 18. I'm going to divide by 18. So I got y is equal to 3. So I found my y value. Now I got to find the x. This is where it starts to get easier because all we have to do is you take one of our equations and we're going to substitute what y is. I'm going to take this one here. This one or this one, it doesn't matter. So I'm going to do negative 2x plus 5 times y being 3, is equal to 1. So I got negative 2x plus 15 is equal to 1. I'm going to subtract 15 to both sides. So I got negative 2x is equal to negative 14 because 1 minus 15 is negative 14. And I divide both sides by negative 2. And I got x is equal to 7. Okay. So we now have our x. We have our x. We have our y. Now we got to get our z. And that is the easy part. We pick one of these top ones over here. It doesn't matter which one. I'm going to pick this guy here because generally they're small numbers. So I'm going to take 2x, 2 times x being 7, plus y is 3. And we don't know what z is, and it's equal to 15. So we're going to solve 2 times 7 is 14, plus 3, plus z equals 15. We're going to take 17 plus z equals 15. We're going to subtract 17 to both sides. So we got z is equal to negative 2. So we found our x, our y, and our z. And we write it as a point. X first, 7, comma, 3, comma, negative 2. And this is the point in which all of these lines will intersect. Now, what's interesting about this is it's 3 variables. So it's 3 lines. It's like these lines are sticking out of the paper. So these 3 lines are intersecting out of the paper, and they all cross at the point 7, comma, 3, comma, negative 2. Okay, so it's a 3-dimensional plane when we introduce the z variable. Okay, so now let's do another one here. But this time we're going to use the multiplication property of equality quite a bit here. Okay, to be able to get this 3 by 3 down to 2 by 2 to solve for an individual variable. okay? So to do that, I'm gonna look and I'm gonna see, is there any variables I could eliminate right off the bat? Well, I got 1 and 3. I could eliminate those y's there. So I'm gonna label these 1, 2, and 3. So I'm gonna take 1 plus 3. I'm gonna start with that one first. So I'm gonna take 4x plus y minus 3z is equal to -6. And I got 5x minus y minus 7z is equal to -19. Okay, by doing that, it's going to eliminate my y's so that I have 9x minus 10z is equal to -25. And I'm going to put it over here. So 9x minus 10z is equal to -25. Okay, now I'm going to say, okay, what is another set of equations that I could do? So if I look here, I'm going to take 1. And I want to eliminate my y's. So I'm going to take the first one and the second one, but I'm going to multiply the first one by -4. And then I'm going to add that to the second one. Okay? So if I multiply -4 to this one, this is going to, -4 times 4 is -16x. -4 times y is -4y. -4 times 3z is positive 12z. And then this is equal to -4 times -6 is positive 24. Okay, so I just took the first one and multiplied by -4. Now I'm going to take the second one and rewrite it. -2x plus 4y plus 2z is equal to 38. Okay, and by doing that, I can eliminate my y's here. So I have -18x plus 14z is equal to 62. Okay, so I'm going to put that underneath this one. -18x plus 14z is equal to 62. Okay. Okay, so now that I have my 3x3s condensed down to a 2x2, I need to eliminate my other one of my variables here. So I need to decide, do I eliminate my x's or do I eliminate my z's? And to me, the one that would probably be the easiest to eliminate would be the x's, because I would only have to multiply the top one by 2 to give us a positive 18 to cross those out. So I'm going to multiply the top one by 2. So this is going to give me 18x minus 20z. See, I multiply 2 times -10 gives me -20z. And 2 times -25 is -50. And then the bottom one, I'm going to rewrite it. Okay. And by doing that, I eliminate my x's. -20z plus 14z is -6z. And 62 minus 50 is 12. Then I'm going to divide by -6. So I got z is equal to -2. So I found what z is. Z is -2. I'm going to take that and I'm going to plug it back in one of these equations. I'm going to plug it back into this first one. So I have 9x minus 10 times -2 is equal to -25. That's 9x plus 20, because -10 and -2 is positive 20, equals -25. Then I'm going to subtract 20, trying to get x by itself. And this gives me 9x is equal to -45. Divide by 9 because 9 is being multiplied by x, so we got to do the opposite. And that gives me x equals -5. -5. So I found what x is. X is -5. Okay, so I got my x, I got my z, and now I just gotta find y. How I do that is I'm gonna put it back into one of these equations, here. It doesn't matter which one I choose. I'm going to do the first one. I don't know. Something about the first one stands out to me. So I'm going to do the first one. So I got 4x, x being -5, plus y minus 3 times z. Well, z is -2 is equal to -6. Okay? And I'm going to solve here. -20 plus y. -6 and -2 is +6 equals -6. I'm going to combine like these two terms here. This gives me y minus 14 equals -6. I'm going to add 14 to both sides. So I got y equals 8. And if you look at that, I got my x, I got my y right here, and I got my z. I write it as a point. So my point would be -5, 8, -2. And that is the point where all three of these lines are going to intersect. Okay, so let's do one more. Okay, so for this one here, we want to try and eliminate one of the variables here. Okay, I want to eliminate my x's. I've decided that that's the variable I want to eliminate. Okay, so in order for me to eliminate my x's, I'm going to take my three equations. I'm going to take the first equation and I'm going to add it to the third equation, but I have to eliminate the x's. So to eliminate the x's, I would have to multiply the third equation by 2. So I'm going to take 2 times the third equation. Okay, so I'm going to rewrite the first one. Okay, and then the third one I'm going to multiply by 2. So 2 times -2 is -4x. 2 times y gives me a positive 2y. Okay, because I took 2 times this gives me -4x. And then I'm going to take 2 times 4z. That would give me 8z. And 2 times 27 is 54. Okay, so I took the second one and I multiplied it by 2. Okay, so when I do that, you'll notice that my x is crossed out, my y is crossed out, and I'm left with 3z plus 8z is 11z, and 54 plus 23 is going to give me 77. Okay, and then I'm going to divide both sides by 11. This is going to give me z is equal to 7. That one was nice because it crossed out it got rid of two variables at the same time. So we found z. Okay. Well, now that we found z, what we could do is we could plug our z back into these two equations to put it in terms of x and y. Okay, so I could take the first equation with those z's, or what I could do is I could take equation 1 and 2 and put those together. Okay, but I'm going to plug the 7 into both of these. So I got 4x minus 2y plus 3 times 7 equals 23. And now I'm going to do the third one. Negative 2x. Well, if I do that, you know what? I'm going to set up my other system. Okay. So I'm going to take the first equation plus 4 times the second equation. Okay, so I'm going to take the first equation, 4x minus 2y plus 3z equals 23. And I'm going to take 4 times the second one, so that would give us negative 4x times negative 4 times 5 is negative 20y. And negative 4 times -3 would give us positive 12z. And -4 times -37 would give us 100 and positive 148. Okay. So when I do that, those x's would cross out. I would then be left with -22y plus 15z is equal to 23 plus 148. That would give me 171. Okay. Then I'm going to take equation number 2. I'm going to multiply that one by 2. And I'm going to add that to the third equation. Okay. So if I multiply the second one by 2, that would give me 2x plus 10y, because 2 times 5 is 10. And 2 times -3 gives us -6z. And 2 times -37 would give us 74. -74. And then I'm going to take the third equation, which we said was -2x plus y plus 4z is equal to 27. The x's would cross out. I would then be left with 11y minus 2z is equal to -74 plus 27 gives me -47. And so I have my two systems. I'm going to take this guy up here. And 11y minus 2z equals -47. Okay. Now, what I could do is I could plug in my z's at any time. Okay. So I could plug those z's into here and I could solve, or I could, because I want to try and find what y is. Okay. This is set up to eliminate the y. I don't know if I really technically want to eliminate the y there. So what I'll do is I'll take what z is. I mean, z is 7. I'll put it into one of them and it'll solve for y. So I'll take 11y minus 2 times 7 equals -47. And then we'll solve there. Let's just save the time there. Okay. Then I'm going to add 14 to both sides. So I got 11y is equal to -47 plus 14 gives me -33. Divide by 11. We got y equals -3. Okay, so we got our z, we got our y, now we just gotta find our x. We're gonna put it back into one of the equations. I'm gonna put it back in the second one. So this is x plus 5y, y is -3, and z is 7 is equal to -37. So I'm using the second equation. And I'm gonna solve x minus 15 minus 21 equals -37. I'm gonna combine like terms, we got x, I got x minus 36 is equal to -37. I'm going to add 36 to both sides. I got x equals -1. So I found all of my variables, x, y, and z. We write it as a point. So that point would be -1, comma, -3, comma, 7. And there you go. That's the point in which those three lines are going to intersect. Okay, so there we go. That's how we solve a 3x3 system of equations. Now, the last thing I'm going to show you is how you could check your answer using the graphing calculator and how to use that graphing calculator to assist us in being able to solve these 3x3s. We can even do 4x4s, 5x5s, all of those. Okay, so I'm going to share my screen with the graphing calculator on it. Just like that. Okay, and we should have this up now. Make sure, yep. Okay, and now what I'm going to do is step by step with our graphing calculator here. This only works on like a graphing calculator I have up here, which is like TI-84. Other than that, you'll have to do this by hand. So it's very important that we know how to do both of these. Okay. Desmos does not do 3x3 systems. It will do 2x2s, but not these 3x3s. So what I'm gonna do is I'm gonna do the last question that we did. Okay, I'm gonna do what exercise 4 was. So first thing I'm gonna do is I'm gonna hit the blue button, this x to the -1. See how in blue it says matrix. So by doing the second key, that's shift, and I'm gonna hit that, and it's gonna give us the matrix. We're gonna scroll over to edit, okay? And we're gonna press enter on that. And you'll notice I entered in all of the values already. But let's say you had values already in here. What you could do is you could clear out all of this. You just change all the numbers, they'll clear it out. Or you could just use a different matrix. Okay, so I entered in all the values and I did the Lie coefficients to each of the variables. So for like the first equation, it was 4x, so I just put it in a 4. Then -2y, I put it in a -2. And then I put a 3z, well, and then I just put a 3, and then it was equal to 23. Now, when you put in negatives, make sure you put in the negative, which is down here underneath the 3, and not a subtraction sign. Because by putting a subtraction sign, it's going to come out with an error message. So try not to do that. Okay, so once we have our matrix filled in, and the reason I'm doing a 3x4 is because I had like 4 different terms. I'm going to then hit second quit. I'm going to go back to it. So I'm going to hit second matrix again. I'm going to scroll over to math. And I'm going to go down to a thing known as reduce row echelon, which is RREF. This is the computations that the calculator is doing to be able to find X, Y, and Z. So all of the work that we just did is called technically reduced row echelon form. So I'm going to press enter. And then I need to put in the matrix. So I have to go back to it. So I'm going to hit second matrix. And I'm going to press enter on the first one, highlighting the one that we entered in our values. Close the parentheses and press enter. And you'll notice that it gives us this matrix here. Now the first value here represents our X. In the next column is our Y, and in the third column is our Z. So X would be -1, Y would be -3, and Z would be 7. And that is, if we go back to our screen, that is what we got. -1, -3, 7. Okay, so that's how you solve a system of equations, and whether you're using elimination or substitution. It's very important that you are practicing this, so make sure you get your homework complete. Jot down any questions that you have, and I would love to answer those questions, okay? I wish you the best, enjoy, and have a wonderful day. Bye.